Welcome to today's video where we discuss about the informed search techniques that are generate test and algorithm and hill climbing algorithm and its types. So, before we move on to the algorithm directly, we need to know a little background of it, where the search algorithm comes into picture. And in the search algorithms, we have two different types of algorithms. One is informed search, and another is uninformed search. Uninformed search is also known as brute force search, and informed search is known as heuristic search because it uses the heuristic function. And main types of informed searches are generate and test algorithm and hill climbing algorithm. So let's jump onto it. Yeah, generate and test algorithm. There is an algorithm which is very simple and that guarantees to find a solution if done systematically and there exists a solution. So the algorithm goes in this way: generate a possible solution at the beginning and test if it and test to see if is the expected solution. If the solution has been found, quit, else go to step one. Means once we find the solution, we have to stop. Otherwise, if the solution is not the expected solution, we need to travel back to the step one and generate another possible solution and check if it is the goal solution we want. And if it is, then we have to quit the steps. And generate and test like depth first search requires that complete solutions be generated for testing. In its more systematic form, it's only an exhaustive search for the problem space. And generate and test algorithm is also known as British Museum algorithm. Yeah, and the second type is hill climbing algorithm. And hill climbing algorithm is a heuristic search used for mathematical optimization problems in the field of artificial intelligence. Given a large set of inputs and good heuristic search function, it tries to find a sufficiently good solution to the problem. This solution may not be the goal or optimal maximum. In the above definition, mathematical optimization problems implies that hill climbing algorithm solves the problem where we need to maximize or minimize a given real function by choosing values from different given inputs. Example, traveling salesman problem as we seen in the basics of operational research, where we need to minimize the distance traveled by salesman and he has to visit all the cities. Hill climbing is a variant of generate and test algorithm as it takes a feedback from test procedure. Then this feedback is utilized by the generator in deciding the next move in search space. So the algorithm goes in this way. It is also known as a local search algorithm, which continuously moves in a direction of increasing elevation to find the peak of mountain or the best solution to the problem. It terminates when it reaches the peak value where no neighbor has a higher value. It is also known as greedy local search as it only looks for a good immediate neighbor state and not beyond that. Hill climbing is mostly used when a good heuristic is available. In this algorithm, we don't need to maintain and handle the search tree or graph as it only keeps a single current state. So these are the features of hill climbing algorithm. It's one of the generate and test variant where the generate and test method to produce feedback which help to decide in which direction to move the search space. It is a greedy approach, means hill climbing algorithm search moves in the direction which optimizes the cost. No backtracking. It does not backtrack the search space as it does not remember the previous states. So these are the main types of hill climbing: simple hill climbing, steepest ascent hill climbing, steepest ascent hill climbing, stochastic hill climbing, and simulated annealing hill climbing. So let's jump on to the simple hill climbing algorithm. It is one of the simplest way to implement a hill climbing algorithm. It only evaluates the neighbor node state at a time and select the first one which optimizes current cost and is set to a current state. It only checks its one successor state, and if it finds better than the current state, then move else move else be in the same way. This algorithm has the following features: less time consuming and less optimal solution, and the solution is not guaranteed. Where in the generating test, we use it for the problems in which solution is guaranteed. Simple hill climbing algorithm, it examines the neighboring nodes one by one and selects first neighboring node, which optimizes the current state as the next node. Uh, these are the steps involved in the algorithm. Evaluate the initial state. If it's goal state, then stop, return to success. Otherwise, make an initial state as a current state. Step 2, loop until the solution is found or there are no new operators present, which can be applied to current state. The substates are: select a state that has not been yet applied to the current state and apply it to produce a new state. Perform these to evaluate a new state. And if the current state is a goal state, then stop and return success. If it is better than the current state, make it current state and proceed further. If it is not better than current state, then continue to loop until the solution is found. Step 3, exit once the solution is found. So this is the second type of hill climbing algorithm, which is steepest ascent hill climbing algorithm. The steepest ascent hill climbing algorithm is a variation of simple hill climbing algorithm. This algorithm examines all the neighboring nodes of a current state and selects one of the neighbor node which is closest to the goal state. The algorithm consumes more time as it searches for multiple neighbors. Algorithm involves these three steps in it, and the steps looks like: evaluate the initial state. If it's a goal state, then return to success. Stop, else make the current state as initial state. It is one of the step taken from a simple programming algorithm, we can say. Step 2, loop until the solution is found or the current state does not change. Let successor, this which is represented as SUCC, be a state such that any successor of the current state will be better than it. For each operator that applies to the current state, apply a new operator and generate a new state. Evaluate the new state. If it's a goal state, then return it and quit. Else, compare it to the successor state. If it's better than the success state, then set a new state as successor state. If the successor state is better than the current state, then set successor state as successor, means remain the same. And then once the solution is found, we can exit. And the third type of hill climbing algorithm is stochastic hill climbing algorithm. Stochastic hill climbing does not examine for all its neighbor before moving. Rather, the searches algorithm selects one neighbor node at random and decides whether to choose as its current state or examine another state. And let's look at the fourth step of and let's look at the fourth type of simulated annealing. A hill climbing algorithm which never makes a move towards a lower value, guaranteed to be incomplete because it gets stuck on local maximum. And if it applies on a random walk by moving a successor, then it may be complete but not efficient. Simulated annealing is an algorithm which yields both efficiency and completeness. In mechanical term, annealing is a process of hardening a metal or glass to higher temperature than cooling gradually. So this allows the metal to reach lower energy crystalline state. The same process is used in simulated annealing, in which algorithm picks a random move instead of picking the best move. If the random move improvises state, then it follows the same path. Otherwise, the algorithm follows a path which has a probability of less than one, or it moves downhill or chooses a path. So these are all about the informed search techniques, which includes generated test algorithm and the hill climbing algorithm and its types as we have seen. Thank you.